All right, section 1.5. This is called, what do they call this? Rational expressions. Whenever you see that word rational, what word do you see in that word rational? Ratio. Okay? And so what is a ratio, basically? Just in everyday terms. It's a fraction, exactly, okay? So when we talk about rational expressions, now when we see expressions, this is when we're not really solving for x, we're just simplifying when you see an expression. So if I saw this, like 3x plus y, that's an expression. You can't really solve for anything, can you? It's not an equation until you have a what? An equal sign, right? So if I had 3x plus y equals something, maybe you could solve for it, okay? So when we talk about an expression, we're just talking about simplifying a polynomial, basically, or an expression. In this case, it's rational, so what kind of things are we going to see here? We're going to see fractions, right? Now, don't let that scare you off, because that's not really that big of a deal when we talk about fractions here. For instance, what if I gave you something like this? What if I said, let's just go back to the tried and true rule that we've learned. Let's go like this, x to the... What if we had this? You know what to do here, don't you? Right? You could subtract the exponents, or I like to think of it this way sometimes. I got two x's up here, and how many do I have up here? I have 5 of them. So 2 of these x's will cancel out with what? 2 of these x's. How many are going to be left with then? 3 of them, because 2 of them canceled out, right? So I got 3 left, so that's just x cubed. Does that make sense? That's a nice, easy way to think about it. What if I had something like this? What if I had x plus, let's do this. Let's go what if I had something like this, and I asked you to simplify this expression? This is a rational expression because it's a fraction, okay? But what can we do? Look at the x plus 5s first. Am I going to distribute that 3 through these? Is that really what I want to do here? No. What can you do? You want to simplify it. So I've got, this is being multiplied. This x plus 5 in parentheses is being multiplied by this 3, and this x plus 5 is being multiplied by this 6. What can I do with those two? Cancel them out. That's right. Okay, cancel that and that. Now what do I have? I got a 3 and a 6 here. Well, what goes into both of those? 3 goes into 3 once, and 3 goes into 6 twice. What's my answer? It's just 1/2. That's the kind of stuff that we're going to be doing. Does that make sense? Let me think of something else. That's good enough, right? You got the idea as far as how to cancel stuff out? All right. Now you can only cancel. Now watch this. What if you had this? What do you do here? Cancel out the 3's. I got a 3 on the top, 3 on the bottom, right? You're agreeing with me just because I say yeah? No, you can't. Can you do that? I don't know. Can you? I'll tell you what. Let's just, instead of making this x, let's stick an actual number in there. I don't know. Call it a 5. Okay? This is what a lot of people would like to do. All right? It's not right, but a lot of people want to do this. A lot of people say, oh, 3 goes into 3. They cancel out. All right? And then your answer is 5. But if you actually did the math here, what's 5 plus 3? 8. Is 8 over 3 the same as 5? Okay, no, it's not. So can you cancel out the 3 and the 3? No, you can't. The reason you can't is because this is being added. That 3 is being added to something. And the only way that you could cancel something out, watch this. Let's change it. What if I did this? Now could I cancel the 3's? All right, Daniel, you watching? So watch, this 3 and this 3, will they cancel now? Yeah, because what's this 3 doing to this 5? It's being multiplied. There's a big difference. Now watch. When I say we cancel out, we use the word cancel out for a lot of things. And I try, when I'm doing these things, I try not to say cancel out all the time. I don't really mind that much if you say cancel, but I want you to know why you're canceling things out. Because look, this 3 is being multiplied, and this 3 down here is being divided. What's multiplication and division? They're inverse operations of each other, aren't they? Isn't multiplication and division opposites of each other? Yeah, if they're opposites of each other, yeah, then they can cancel out. But look at this. Is addition and division opposites or inverses of each other? No, they're not. All right, so you can't cancel out. If this is being added and this is being divided, you cannot cancel them out. Does it make sense? You can only cancel out in this situation when this is being multiplied and divided. They're inverse operations and they will go. And so your answer on this one absolutely is 5, but it's not up here. You got it? All right, that's one of the key things that you need to remember. All right, let's write down an example of the kind of stuff that you're going to see, and we'll go from there. Okay, here we go. Here's an example, and it says to simplify is basically what it says, or it says express it in lowest terms. Express the expression, the rational expression, in lowest terms, which means just simplify things. Now look, can we just start canceling stuff out? Look, I see an x squared here and an x squared here. Can we cancel that and that out? You say, well, x squared is being multiplied by 2, and this x squared is being multiplied by 5. We said if they're being multiplied by something, we can cancel them out, right? But yeah, this is being multiplied by 2, but what's this whole term doing, though? It's being added to something, isn't it? All right, if that's part of a term that's being added to something else, you can't just cancel out the x squareds, all right? Because really, even though it is being multiplied by 2, it's part of an addition problem. You got it? So I can't just cancel out the x squareds. What about the x's? Can I cancel out the x's? Same reason, I can't do it because this term right here is being added to something else. So is this. I can't just cancel out the x's. So what I need to do is I need to make it so that it's something times something. I need some multiplication up top. And we just finished doing this in the last test. What do I do to this thing right here to make it something times something? What's the word? Well, we did a ton of this in the last test. What's that? What do I do to this to make it something times something else? I factor it, right? Okay, I want to find the factors, and that's what I'm going to do. So I'm going to find the factors of this. Now, just for the sake of time, I'm going to write down what the factors are. Okay, we're not going to go through that whole process. We did that in the last section. You can work on that on your own if you want to. This is 2p minus 1, and this is p plus 4. I said I knew it. I was going to do that. I knew it. Why didn't you stop? It's 2x, right? Because I'm looking at the example here, and it's x plus 4. All right. So that's that thing factored right here. This is a little easier factoring. This is not a regular trinomial factoring, but what's in common with both of these? What's the greatest common factor? 5 goes into both of those. What else goes into both of them? An x. So if you factor out a 5x, you have x plus, divide that by this, and you get 4. Good. Now here's what we have. Now it's pretty easy to see. That was all the work. The actual simplifying the expression part and the canceling, that's the easy part of this. Because look what I got. I get x plus 4 on the top, I get an x plus 4 on the bottom. I can cancel, right, because this whole thing, even there's a plus in between the two, look at that whole parentheses. What's that whole parentheses doing? It's multiplying. What is this whole parentheses doing? It's multiplying. So can I just cancel them out? Yeah, because division and multiplication are inverses of each other, so they do go, all right? They become a 1, don't they? Because when you have something over something else, that's 1, okay? What about this? This is 2x minus 1, and this is 5x. Did the x's cancel here? No, because that 2x is part of a subtraction problem, isn't it? So it's exactly right. So all it is 2x minus 1 over 5x, and that's all you can do. There's nothing else you can do with that. Make sense? That's all there is to that. All right, let's try another one. All right, here's another one. Looks kind of similar. Let's see, do the k's cancel? No, because this is part of subtraction, this is part of subtraction, so you can't do that. So most of the time when we do these problems, we factor the top and the bottom. All right, I would say most of the time we factor the top, we factor the bottom. So look at the top. Is there a common factor there? Yeah, 3. So 3 goes into that what? Twice minus what? K. And on the bottom, this is a sum of 2 squares. Do you remember that from the last chapter or last test? It's a sum of 2 squares. So 1 is plus, 1 is minus. Put a k here and a k here, and what? 2. All right. So we factored the top and the bottom. Now, over here, we factored the top and bottom. Boom, boom. They just canceled out. I got the same exact thing on the top as I did on the bottom. They kind of rig it that way, don't they? But look at this right here. Do I have the same thing on the top and the bottom? Not really. This is 2 minus k, and this is k minus 2. Is that the same thing? No. Is 5 minus 2 the same as 2 minus 5? No, it's not. What's different is the one's going to come out positive, one's going to come out negative. So what I'm going to do is this. I need a way to switch that around. Now you could say negative k plus 2. That would be okay. All right. And if you wanted to, I don't know if you want to do that or not, but I'm going to. watch, negative k plus 2 is, now, just by switching it around, did that really help? No. It's still not the same thing, is it? But what I'm going to do is this. Remember, on a fraction right here, if I multiply something by the top and I multiply the same exact thing on the bottom, really all I'm doing is multiplying it by a 1, right? We talked about that before. The same thing on the top and bottom is just a 1. Here's a little trick. What we're going to do is we're going to multiply the top by a negative. Now I want to get something straight. What if I did this? What if I did 2 times 5 and I wanted to multiply this by a negative? I could either multiply the 2 by a negative, right? Because what would that give you? Negative 10, right? Or I could do what? Multiply the 5 by a negative, and that would give you negative 10. The same thing, agreed? I don't multiply them both by negatives, do I? Because if I multiply them both by a negative, what would I get? Positive 10, all right? So that's not the opposite sign. So over here, what I'm going to do is I'm going to actually take this thing right here, multiply this by a negative, all right? Now, as long as I do that to the bottom, I'm okay. I can do that. What happens if I multiply this by a negative? So I'll tell you what, let's slide this down here. Watch. I'm going to go 3, and let's see, I'm trying to think of the best way to write this out. Let's write it like this. Negative k plus 2. And let's put the negative 1 right here. Is that all right? All right, because I didn't want to put it here because I don't want you thinking the 3 is going to become negative, and I didn't want to put it in between because it would look like 3 minus, all right? So I'll put it on the outside like this. Let's just work with the top, and then we'll mess with the bottom here in a second. Now, watch what happens. That's still a 3, isn't it? Look what happens when I multiply this by a negative 1. What does it become? It becomes k, what? Minus 2. That's right. Now look, I had a k minus 2 down here on the bottom, didn't I? But look, I can't just multiply the top by a negative 1 and not change the bottom. I still have to multiply the bottom by a negative 1. But which one are we going to multiply by a negative 1? Well, look, I want this k minus 2 to stay right here, don't I? So I'm not going to change this one, because if I change this, let's see, if I change this one, I still won't have anything that's the same on the top and the bottom. So I don't want to change this one. I want to keep this one the same, don't I? Which one am I going to change, though? I'm going to change this one right here. So what's that become? Negative k minus 2. Do you see that? So look, I multiply the top by a negative 1, and I also multiply the bottom by a negative 1. I'm allowed to do that, because what's negative 1 over negative 1? It's just a positive 1. Multiplying by a positive 1, does that change the value of that at all? No, it doesn't. All right, but it's kind of a little trick. It's a trick because multiplying this by a negative 1 changes it to something that I wanted. Changes it to a k minus 2. But I got to do that to the bottom as well. So what do? I change this one, because I want this one to stay the same. I don't want that one to change. So I kept that k minus 2, multiplied this one by a negative 1, and I've got this. Now look what we can do. A little bit of sleight of hand, right? With the negative 1 over negative 1 is kind of a little trick that we had to do. So now look what happens. That cancels with that, and what are we left with? It's just 3 over negative k minus 2. All right? And you can leave your answer just like that if you wanted to. You may see it written a little differently. Watch. I'll just show you. You could factor out a k. I'll show you why I'm doing this. You could write it like this. Now remember, like if you had a fraction, like negative 3/4, does it matter if the negative is on the 3 or the 4? It's still the same thing. It's still negative 3/4, isn't it? So I could take this and pop it up top. So I'm running out of room here, but it's watch. I could write it negative 3 over k plus 2. That is the exact same thing as that. You may see it written, right, when I read the answers off or I give you the answer key, you may see it written like this, but if you want to keep it this way, I'm perfectly fine with that. You all right with that? Okay. All right, we good with that? All right, let's go to another type.